the next few videos I'm going to run through some examples on how to determine the frequency response of electrical circuits using impedance methods. I'm going to do a few very basic examples, but they all follow the same process, so if you get your head around these few examples you should be able to analyze any basic electrical circuit. So the example I'm going to use first of all is a resistor in series with a capacitor. The supply voltage I've labelled as Vin, and the output voltage is the voltage across the capacitor in this system. So I'll just have the expression up here, which is the general expression for the frequency response of the system. So mathematically we notate the frequency response as h omega, and it's equal to the frequency content of the output all over the frequency content of the input. So we want to get the output all over the input, okay, and that will give us the frequency response. Now the reactance methods are very straightforward, so let's just go through with this example. So in this case the output voltage V out will be equal to the input voltage V in multiplied by the impedance of the capacitor all over the impedance of the capacitor plus the impedance of the resistor. That's just using the basic potential divider rule. Okay. Now the impedance of the capacitor is 1 over j omega c. The impedance of the resistor will just be R. So let's substitute those values in and we'll expand out the expression a little bit. So V out will be equal to V in all over 1 over j omega c all over 1 over j omega c plus R. Now the frequency response of course is V out all over V in, and I can get an expression in this form just by bringing V in across the equal sign, and that will mean that V out over V in is equal to 1 over j omega c all over 1 over j omega c plus R. And that's the frequency response. Now it normally helps to simplify that expression a little bit, and that can be done in this case by multiplying above and below by j omega c, and this isn't really necessary, but it just simplifies the expression just a little bit. So I'm going to multiply above and below by j omega c, and that would give me 1 all over 1 plus j omega over c. Okay, so that's how you get the frequency response of this basic circuit here. You'll see that the same process is always followed. You're looking for an expression in this form, the output over the input, and you can use various techniques to get to that stage. So I'll run through a couple more videos on how to do that.